What's up, CoderBite? Welcome back to another data structures and algorithms video. We're here today with another video in our Back to Basics series where we're going over, just random good interview problems, and I'm just live coding them and trying to solve them for you just right before your eyes. This problem comes from an actual interview problem I got at my current job. My current manager I also worked with him at my last company. He was our team lead at my last company. He recruited me for this next job. But we're trying to interview people now to fill some positions on our team. And he reminded me of this question, which he asked me at the last job that I worked with him at. So hope you enjoy this. This question has worked out for me, obviously, positively. So it means something to me a little bit. And it's a good one. So let's get into it. This week's problem. Write a function to flatten a JSON object with nested keys into a single level. Okay, so this is pretty simple right off the bat. I think we've all seen JSON and how it can have, deeply nested properties where there are objects inside the object, arrays, etc., and it can go kind of endlessly deeply nested. So this is a pretty common thing in normalizing data or pulling out all of those fields. And essentially, we want to still retain the structure of the JSON. We want to know that something might have been deeply nested, but we want to have everything in a single level in the JSON. So let's look at an example really quick. So here we have a large object. The keys are places, and you can see that we have some kind of, there's the first level, which is countries, United States, Canada, Mexico, and then there are some deeply nested things, states in the United States, cities, New Jersey, New York, etc. And then there are even further nested keys, which are neighborhoods or areas. So here we have Newark and Brooklyn and Manhattan. And finally, in each of these, for this example, I just put some friends or people I know who live in those places. And you can see that we have strings, we have arrays, but essentially we have some nesting, and it could be infinitely nested. We're not sure how many levels there are, right? So we want to go from this structure to something that looks more like this, which is just one, there's just one level to this JSON, and you can see that each key is retained, and then we append to the key with an underscore the nested keys inside. So here we have the key United States underscore New Jersey underscore Newark underscore 0 Jeremy, because at the 0th index here we have Jeremy. And then underscore 1 we have Stacy, because she's the second person in this array, right? And etc. This is pretty self-explanatory. All right, so let's code this baby up. Okay, so we're going to use Python again just because we're trying to change things up. Maybe people like Python as well. And as per usual, I am in PyCharm, and I just have a file called flatten.py. So as per usual, I'm going to add my, if dunder name is main, run our function. So if dunder name equals main, right? We're going to call, let's, say flatten JSON. And let's define flatten JSON. And that's going to take our object. And I can just put pass in there so it doesn't hate me. Okay, so we're all set. So I think what is important for this question particularly is that we don't know how deeply nested is this nested JSON, right? We don't know exactly how far we'll have to traverse. So immediately I'm thinking recursion, because we can't just use a loop, right? For I equals 3 and then loop through 3 levels, we might have infinitely nested fields. So we are going to have to do some recursion in order to kind of continue until we've hit some base case or something. So right off the bat, whenever I think of recursion, the first thing I like to think of is, what are my base cases? Because that's the building blocks of your recursive function. The base cases really represent when you're signaling to the computer, hey, stop, right? We've finished something here. And so for this, I think, first of all, let's get our example in the editor so that we can actually, talk about something and know what we're talking about. So I'm just going to copy the example I had in the slides here. Let's say nested obj equals that. So here we have our nested object, and we're going to pass that in here, right? And I guess we can also print because we know that we're going to want to see what we get from this function. Okay, so let's talk about our base cases. I think our base cases will always be if the value, right? If the value at a certain property or key is an object or a list, or actually I think only if it's an object, we want to continue to recurse, right? We want to continue to go down. If it's a string or an integer or a list, we're going to want to do something, right? We're going to want to somehow capture that and then signal to the function that we've reached our end. So I think what we'll want to do is the first thing we want to do is we're going to want to return an object, right? So this is going to take, we're going to want to return our object with our single level. So let's say like our return here is that, and we're definitely going to return that, right? Return the red. Okay, so this is going to be the object with the single key. And I think for this function, we might want to create another function within flatten JSON, because what we want to do is we actually want to not recurse over this whole object, but really we want to, for each of these keys, we want to recurse over its, quote unquote children, right? So we want to, for the United States, we want to capture United States and recurse all the way down. And so that's going to be it's going to be one branch of our recursion, and we're going to have a branch of recursion that we set off for each of these top level keys. So I think for that, we're going to want to have another function in here that's going to be the function that we actually recursively call. So let's say this is just, flatten. And what this is going to take the object, right? We're going to want to flatten X or whatever. I don't think we can call it an object because it might not be an object. It might be an array, or it might be actually just the end of the line, right? So an integer or a string or whatever. So I'm just going to call this X because it's kind of arbitrary, like what's happening here. And I think the second argument for this function is going to be that the key, right? Because we're going to have to, with each recursive call, we're going to have to keep track of the key that we build, right? We're going to want to have United States underscore New Jersey underscore Newark. And even though we're calling the function over and over recursively, we still want to retain what that key is that we're trying to build here. So I think the second argument is going to be the key. And the key, if we don't have one yet, we want to initialize it, right? So I think we can just set it to be an empty string, and that's kind of signifying that we haven't started yet. We're at the beginning of the recursive call. Okay, so we have flatten JSON, which is going to keep track of our kind of big object that we're going to actually return. And then we have this little function, flatten, and this is going to be the thing that we call for every single key in the nested JSON. Okay, so what are our base cases here? I think our base cases are, right, if we're not at a list and we're not at an object, right? That's the base case here. And at that point, I think that what we'll want to do is we will want to take that key, right? This is the flattened key. Let's rename that. We're going to want to take that key and add it to our return object, right? That's our base case here. So at that point, we want to set this flattened key, we want to put it on our out object, our ret object, right? And we essentially want to set it to whatever we are at in the recursive call. And at that point, that will be x, right? The base case is that x is an integer or a string. So we're just going to set that equal to x, right? So this is going to be an else because we're going to have a few other ifs, but I'm going to make a comment here. This is x is equal to a string, integer, etc, Boolean, whatever, right? Okay, so that's kind of our base case here, right? So what about if it's not, if it's an object or a list? So let's go through if it's a list first. So let's say if the type of x is list, what do we want to do? We don't want to recurse at that stage, right? We just want to loop through this list and append the index of where we are in the list to the key. So in this case, we can just do something like, for lm in x, so now we're looping through that list, we want to call flatten with each element, because then what we do in this case is we want to basically end up in our base case, right? This is where we want to ultimately end up. So we will call flatten, which with each element in the list. And what is the key going to look like? The key is going to basically, we're going to want to get the index, right? The index of where we are in this list. So we can say I is equal to 0 to keep track of the index. And we can say that we want to flatten it, right? We want to call flatten with whatever flattened key we're already at. So this is going to be the flattened key. And then what we're going to want to do is we're going to want to basically just concat that index to the key, right? So we can say that we want to do a string of I, right? And then we just want to add an underscore, right? And that's going to be our new key. And that's how we're going to recurse over this structure. Okay, so that takes care of our lists. So now what do we do if we have an object? So if we have an object, right? So if type of x is a dictionary, right? Because that's what that is in Python. So what we want to do in this case is we want to loop over the keys in the object, right? And we want to recursively flatten each one of those. We want to set off a branch of recursion for each of those, right? While retaining the flattened key that we have. So we can easily do that. We can say for current key in dict, in x at this point, right? We want to call flatten with x at that current key, right? So that's how we're going to we're going to kind of move this function along and continue to pass the nested JSON. And then the key that we want to kind of retain here is we want to take the flattened key, which is what we have from previous, whatever function call parent is calling this particular function right at this stage in the recursion. And we want to add to it the current key plus an underscore, right? And what that will do is that with each call to flatten, we kind of append the nested keys to the original key. Okay, so we're going to have to do some updates here, right? So we have an if here. We're going to have to make this an elif, right? And then here, this is now going to be another else, right? So this is like the base case. Everything else will come here. Okay, so let's see how we did, and let's see what we get when we run this. And so far we haven't actually made any calls to flatten. So let's do that right here. We're just going to, originally, the first thing we do is we're going to flatten it with the object, right? And it's not going to have any keys because it's going to be at the top level. So all of the keys are going to be initialized as empty strings. and it's going to recurse. So let's see what we get here when we run this. Okay. Okay, so we get something, and let's see what we get here. So I'm going to put this into a Scratch file. Where's my Scratch JSON? Okay. And I'm going to do that. And of course, it's all upset because these are single quotes and not double quotes, but that's all right. Okay, so we basically got what we wanted, except now at the end we have extra underscores everywhere, right? So why is that? That is because, let's look at what we have here. Because every single thing in this, when we flatten, we append an underscore after every single key, even when it gets to this stage. So at this stage, it already has an extra appended underscore because of the call before it. So what we can do here is there's a cool thing in Python that you can just kind of in place remove the last character from a string. And the syntax for that is just a colon and then -1. So that will just strip that last thing from the we have to do this too. Okay, so that will just strip the last character from flattened key and return whatever it is minus that last character. And then that should take care of that. So let's see what we get here. Let's copy and paste this. Okay, and that is exactly what we wanted to get, right? We have United States, Newark 0, but we don't have, we have New Jersey, we only have one New Jersey, so why is that? Okay, so here we are, we have Jeremy, right? And so here is our for LM and X, flatten. So that all looks good. So why is that missing Jeremy here? I know, because I'm not updating the index as the loop continues. So let's do that right here. So that will push it along. So let's try this one more time. All right, so now we have exactly what we wanted. So we have United States underscore New Jersey underscore Newark underscore 0, Jeremy underscore 1, Stacy, etc. So whenever I'm doing any recursive problem, or a lot of things really, I find the debugger super useful, but especially when I'm doing anything recursive, because it's helpful to visualize the call stack and exactly what's happening at any given point. So let's go through this. We'll step through the function using a debugger just to kind of visualize exactly what's happening here. So in PyCharm, it's super easy. You can just start to add breakpoints. So I'm going to add a breakpoint here and here and here, and we'll see what we get here. I'll put one there as well. Okay, so let's run this with the debugger. Okay, so this might be hard to see because there's a lot going on here. On the screen. But at this point, we're at the flatten object, right? Object is just the big original nested object. And then ret is obviously an empty dictionary. So let's continue to step through this. Okay, so we're at the first case. If type of X is dict. So let's see, what is X? X is in fact a dict, right? So let's step into and see what's happening. So the current key is United States. The current flattened key is an empty string. And what we do is we go back into the function with whatever is at X of current key, which is the United States. So let's see what happens then. Okay, so we're now in another, this is our first recursive call to flatten. And the flattened key that we have so far is United States underscore. That was from the previous call right here, right? So we can continue to do this again. So at United States, there's another object, right? So this is the dict that we're dealing with at this point. It's the one with New Jersey and New York, etc. So we can continue. So now we're in the New Jersey part of the object, and we've appended New Jersey and another underscore, so we can do it again. Okay, okay. That was the Newark part. So now we're back into if type X is dict. So what is X at this point? X is not a dict anymore. We're at a list, right? So this is the Jeremy Stacy list. So it's going to skip over that and go straight to the elif, right? And it's going to start to loop over the elements in the list. So here we go. We're looping over. We now have this flattened key. I is 0 because we're at the first index of this list. And we are going to go back out into the function. So at this point, what we have, X is finally a string. So we've reached our base case, and we have our key, which we've constructed, which is United States underscore New Jersey underscore Newark underscore 0. So let's see what happens at our base case here. Okay, so here we finally were at a base case. So we want to set this entire key on our return object and strip that last underscore, right? So that's good. Okay, so now we popped that off the stack and we are back in our looping over our list at Stacy, right? So now at this point, Elam is Jeremy. Okay, so first we're in the Jeremy loop, we're finishing it. I is now equal to 1. And now Ellen is going to be Stacy, and we're going to do the same thing. We're going to call flatten with Stacy. It's going to be the same key as before, right? United States underscore New Jersey underscore Newark, except now we're going to append a 1. And here we are. We're at X. X is equal to Stacy. Our key is, that whole thing underscore 1, which is exactly what we want. And we are back in our base case again, and we set another entry in our return object, which will be underscore Newark underscore 1 equals Stacy. And we're back in our loop. We finished over the list, right? So now we are popped back out, and we are back into the looping over the current keys of X. And here we have, that was Newark, so we're going to finish that call, right? And we're going to move on to New Jersey, etc. So I'm not going to continue, but I highly recommend that you all play with this. It's a super powerful tool, understanding any sort of recursive function. It's really helped me in understanding recursion. And yeah, I can't recommend a debugger enough. That's all I got today for you folks. I hope you enjoyed another Back to Basics video. I'm really enjoying these. They're a little less polished, but by design, and I hope that it's, simulates a little bit more of what a real world kind of problem solving might look like. And yeah, look forward to more videos like this coming down the pipeline. And make sure you comment below if you're liking this sort of content. Have a good week, everybody.